derive for you from first principle how this equation comes about. So the 4 conditions that you have to meet before you use it is steady, incompressible, constant density, frictionless, and the fact you can identify a streamline, meaning the flow is not very turbulent, there's a lot of mixing, not in a like in a combustor, or flow going through a fan, or a turbine, the flow is being chopped up turbulently. So that's Bernoulli. So how would you use this Bernoulli equation to do a new problem? And this could be an assignment or would be a good test problem. That now, same flow, same elbow, same geometry, everything is the same except I take away the 10 psig, and I say, assume it's frictionless. What would you do? What would you do to replace that long 10 psig with something that is now called Bernoulli?
Just do Bernoulli for like the in and Bernoulli for the out.
Yep, that's all. You apply Bernoulli from station 1 to 2, which are all equal. You apply Bernoulli from here to here. The velocity can be linked by what equation? V1 and V2 can be coupled by what equation? Say it louder.
Continuity.
You know how to spell continuity? Make sure you spell it right, then you calculate it. All right, no joke. Yeah, V1 and V2 can be coupled by continuity, and now with this, I can solve for P1G. And I don't need to be told, and I don't need to measure that 10 psi, because I'm using Bernoulli, and I assume the flow is frictionless. You get it? Yes?
So because we were told that it had friction, then we had to be told over 10.
Exactly, right. Because you cannot use Bernoulli anymore. Okay? Because the friction will not allow you to use Bernoulli. So you make some assumption and you get an answer that is not as accurate, depending on your need and your application. Sometimes it's good enough, sometimes it's not. Yes?
Do we still develop the friction of the bend, like of the turn? Because there is innate friction to the wall, right? When the water turns.
When you assume there's no friction under the context of Bernoulli,
No, for the problem, as it was stated.
for the original problem,
Yeah.
no. All you need to do is draw the control volume, and because the flow is steady, you don't care what happened inside. Everything happened at the control surfaces. Remember what I said? Right? So that's why to do the problem, you don't need to even look at the last statement in the problem, which is the flow is not frictionless. It's there just so that you don't use Bernoulli. Right? So the friction inside the control volume, it happened. In this context, it's not needed, based on the control volume analysis. Okay? Fair question, yes?
Is the elbow line flat on a table?
The album what?
Is it lying flat on a table?
I can't remember the problem statement. Anyone remember?
It says
Yes,
neglect
yes.
gravity.
Yeah, it's neglect gravity, meaning this is on the table. No body weight. No body weight. Yeah. Yes?
So if you had assumed frictionless and used Bernoulli to find like the flow rate, how would your answer differ?
Yeah, that's $1 million question. Can I do that later? Maybe after test 1? No, I'm serious. I think I have enough on my plate. Yeah, those are excellent questions. Will the pressure here, which was given in the problem statement, 10 psig, if I assume Bernoulli, think about what should that be? Less than or greater than 10 psig? And for the same reason, how would the flow rate change? Those are questions that I'd like to refer later. Right? But those are all the right direction and the right questions. So for that, the homework for next time, that has to do with Bernoulli is problem 345, which is something you see in your backyard sometimes. garden hose shooting our water jet. And as the jet come out from the nozzle, eventually what will happen to the jet? Water nozzle shooting to the sky. It will stop. It will stop. And you are given just the height and the area of this nozzle, the height of this water jet, from which you are asked to calculate how much water is coming out in cubic feet per second from this water hose. It's something you have done in 21, 24. I will give you one hint. What is the pressure inside this water jet? Atmospheric. Do you get it? And you agree with that? Okay, it's everywhere atmospheric. And that is all I will give you. Okay, let's take a 2 minutes break.